Hello and welcome. Today's lesson is on atmospheric temperatures. Get ready to learn. We're going to talk about different layers of the atmosphere and how the temperature changes. Did you know air in the atmosphere has several different layers? And the layers are separated by temperature characteristics. In other words, how the temperature changes as you go from sea level to space. Why is it important to know about atmospheric temperature? Well, knowing helps us in understanding pollution, how our planet works. We want to be protecting layers that keep us alive. You've heard of the ozone layer. That keeps us alive, it keeps us healthy. Now, we can directly measure the air temperature. You go out, you take a balloon, you put a box that has instruments in it, measure atmospheric pressure, temperature, where it is, a GPS monitor. And you attach it to a balloon. The balloon goes up until the pressure breaks the balloon and it parachutes down to Earth. And there's an antenna on here so you can get your data. So the balloons carry the instruments, but it only gives measurement for a very small area. In other words, wherever this is where you're measuring. So you have to do a lot of them and then piece together all the information. You can also use satellites. They can directly and sometimes indirectly measure atmospheric temperature. Okay, here we go. We got to figure out where the atmosphere is to start with. Most of the atmosphere, remember, we have air molecules being attracted to the Earth by gravity. So the closer you are to the Earth, the more attraction there is. So think about it. At sea level, you're at the highest density. There's the most air molecules pressing down on you. As you go up from the surface of the Earth, eventually you're going to get to space where there is very little, if any, air molecules. So about 3/4 of the air that we have on the planet is in the troposphere, 6-7 miles up. And then 1/4 is the rest of the atmosphere. Here are mountains down here. So as you go up a mountain, it gets colder. Yeah, we get that. We're in the troposphere. Most of us all of us live here. But as you go up high enough, this tends to change. The air pressure lowers as you go up, so there's not as much air here. And you can see that as you go from the troposphere to the stratosphere, the mesosphere, thermosphere, and as you go out into space, the exosphere, it has different layers based on the way the temperature is going as you go up. You would expect it would get colder as you go higher, and that works in the troposphere. But then you get less and less air molecules, so they heat up until you get to another level, somewhere around 31, 32 miles up, where it starts getting cold again because there's not a lot of air molecules. And then once you get further up, there are less and less air molecules, but they are closer or further away from the denser air. So the sun heats them up and they get hotter, but there's not as many of them. So the layers are separated, so we can talk about it, by the direction of the temperature shift. You see it goes from sea level, it goes down as you go up until you start getting warmer, and then colder, and then warmer again. So layers of the atmosphere are separated by the temperature shift. Now, the exosphere is out here. Space means exo meaning outside. So outside the atmosphere is about 425 miles up. The thermosphere is here, and it's where the space station is. It's where the shuttle used to fly is where the space station is now. The mesosphere, as you go from the exo to the thermosphere to the mesosphere, you're getting more and more air molecules. And that's why meteors burn up here, because in the thermosphere there's not as many air molecules, so there's not a lot of friction. Then we get down to the stratosphere, and you can see how the layers are getting smaller because most of the air is down in this tiny layer at ground level. So the stratosphere is where we fly in planes above the weather. And of course, the troposphere is the most dense part of the atmosphere where everybody lives. Now, all weather happens in the lowest part of the atmosphere, the troposphere. Modern airplanes fly in the stratosphere to avoid the weather turbulence. Nobody wants to fly through a storm. You want no bouncing around, no turbulence that happens when you have high pressure and low pressure and updrafts and downdrafts. So most airplanes fly way up here above the weather. Now, greenhouse gases shift the Earth's temperature. So you have hydrocarbons, CFCs, chlorofluorocarbons. They all affect the greenhouse effect. They change the amount of energy that's bounced in the atmosphere. Then you have the ozone layer, which protects us from harmful ultraviolet radiation just above the stratosphere. So knowing how the Earth works makes us better stewards of the Earth, so we can make it a better place to live. Knowing helps in understanding pollution. Protecting layers keep us alive. And that's why it's important to know about atmospheric temperature. And there's your lesson on atmospheric temperatures.